Everyone, in this video, I'm going to discuss real quickly some factors that affect our breathing. And these are things we discussed earlier in this chapter. However, it's nice to come full circle and see it all again. It's nice that it's also put in a very precise context, right? So, again, all stuff we discussed earlier, we can stretch the tissues. And when that happens, we can inhibit respiration. And this is going to prevent overinflation of the lungs. So, in other words, you take a breath. As you inhale, it's going to stretch these various receptors found throughout the visceral pleura, the bronchioles, and the alveoli. And it's going to tell your body, hey, you already have enough air in here. You don't need any more because it can cause damage. So that's one way we can affect our breathing. Next, we can talk about if you have low blood oxygen. Just like we discussed earlier, if those chemoreceptors, specifically the carotid and aortic bodies, see that, they will tell our body to increase alveolar ventilation. We need more oxygen. This is going to increase our blood concentrations. So again, we notice there's too low of oxygen. The next one, like I mentioned in the earlier video, instead of focusing on oxygen, we have high CO2. Again, we have different chemoreceptors, and they're also going to be triggered. Again, different scenario, it's CO2 instead of oxygen. Different chemoreceptors, same response, right? It's going to tell us that we need to increase our alveolar ventilation. The effect is also different though, right? In the first case, we increased oxygen because we had too low of oxygen. But in this case, we are going to decrease CO2 so that way there's less CO2. Specifically, where in the body are we registering this? In our cerebrospinal fluid. Right? So again, this is going to happen in the brain. So our brain is going to recognize we have too much CO2. So we're going to increase our respirations so we can get rid of that CO2. Then when we have less CO2, the cerebrospinal fluid is going to be able to tell the brain, essentially, we're back to normal. Again, it's another negative feedback loop. And then down here, very similar, cerebrospinal fluid. We have chemosensitive areas of the brain who can recognize the different concentrations of ions. Again, the acidity, if it's high ions of high hydrogen ions, we have a lot of hydrogen ions, that equals low pH, which means acid. And then same idea. Parts of the brain will be able to recognize that through those chemoreceptors and then increase breathing and therefore decrease CO2. So this is the last slide for this chapter. There's a lot going on in this chapter. Please write down any questions you have and come to class with those questions. We can go over anything you'd like. Take your time. There's a lot of terms. Just make sure you feel pretty comfortable with the terms. And if you're having any issues whatsoever, please send me an email or we could talk about this in lab.